All right, so I'm going to find the relative extrema for number 33 using the second derivative test. Okay, first thing I'm going to do is I'm going to pull up that x to make finding the derivative a little bit easier. So I pull up the x by giving it a -1 exponent. Okay, first derivative, I have 1 minus, because the negative comes down, 4, x to the subtract 1, I get -2. Second derivative, I have 8, x to the -3. All right, so finding my critical values, I'm setting my first derivative equal to 0. I'm going to pull that x squared back down and make it positive. I need to solve for x, and I have x squared in the denominator, so I'm going to multiply by x squared to cancel it. But when I do that to one term, I have to do that to all terms. All right, so this is 0 equals x squared minus 4. This is the difference of two squares, so x plus 2 and x minus 2. So I have -2 and +2. Okay, so now I'm going to use the second derivative test, and I'm going to plug -2 into the second derivative. And I'm also going to pull that x to the third back down into the denominator and make it a positive. All right, so I'm going to take out the x. I'm going to put it in a -2. I have a positive over a negative number, which gives me a negative number. And because I got a negative number, that means I have a relative maximum. All right, now I'm going to evaluate 2 into the second derivative. So I have 8 over 2 cubed. Positive over positive is positive, which means that I have a relative minimum at 2. Okay, so now I'm going to plug 2 and -2 back into the original function to find the relative minimums and maximums. Okay, so 2 plus 4 over 2. So this is 2 plus 4 over 2 is 2, so 4. So the first point I get is 2, 4. And 2, 4 is my relative minimum. Okay, now I'm going to plug in -2. When I plug in -2, I have -2 plus 4 over -2. So that's -2 plus -2, which is -4. So -2, -4 is my relative maximum.